Hello everyone, welcome to my channel Yashita Decodes. So in this video we'll be looking at part 2 of chapter 5, file handling. In this part we'll be covering the last two topics, that is working with binary files and working with CSV files. So in the first part we have already covered these topics: introduction, data files, opening and closing files, working with text files, and standard input, output and error streams. Okay, so let's get started. Working with binary files. Binary files are used for storing complex objects because they can store data in the same internal format used by computer zeros and ones. So all the complex objects, okay, like nested objects, like we have this nested structures, list, tuples, dictionary. These complex objects, they are stored in binary files because they can store data in the internal format, okay, used by computer zeros and ones. See, unlike text files, binary files can directly store Python objects such as these dictionary, tuples, list without converting them into strings. See, in text files we saw that even if for storing a numerical value we had to convert it into string, and while reading that string would be converted back into a number. That conversion was required in text files, but in binary file we don't need any such conversion. Okay, we can directly store them in the internal format. So that is why binary files are required, because here the data is stored in a way that their structure and hierarchy is maintained. Pickle module in Python. So Python provides a built-in module called Pickle to store data and retrieve Python objects from binary file. So in order to store data in binary format and retrieve that binary format into our original format, we have this built-in module called Pickle. Pickle module converts Python objects into binary format before storing them in a file. Okay, so what Pickle module is doing, it is converting these Python objects into binary format before storing them in a file, and then they are converting back into Python objects, so that the data which is stored in binary format will be converted back into Python object when we'll be reading from that file. Okay, so that is done using Pickle module. What is serialization? Serialization is the process of converting Python objects into binary format. So when we convert these Python objects into binary format, that process is called serialization. We have to convert these Python objects into binary format for storing them in a binary file, and that process is called serialization. It is done using pickle.dump. Pickle.dump object and file. So we are dumping that data, we are converting that Python object into binary format, and then we will be storing that in a file using pickle.dump. Next is unpickling, deserialization. Unpickling is the process of converting binary data back into Python objects. So we have this binary data stored in binary file. Now we want to read that data, so we want to convert into a Python object. That process is called unpickling. It is done using pickle.load, and syntax is pickle.load file. Okay, so we'll be loading that data, so the binary data will be converted into Python object so that we can read it. Okay, so that is unpickling. Okay, I'll just show you on PyCharm how it's done. Okay, we'll start with writing a dictionary in a binary file. Writing a dictionary in a binary file. So I'll say import pickle. We will open the file. Let's say we are opening a file dict.dat, and we want to write into this file, so we'll say write binary. So this will create a new file called dict.dat, and we want to write this data, which is roll number 101, name Aman, marks 95. So we'll do pickle.dump, and we'll dump this data into our binary file f, and then finally we will close the file. So I'll just right click here and run it. So here this is dict.dat. See, this, it has created a binary file, and obviously it is not readable, and this is the dictionary that is written in binary format here in this form. So this is how we write into a binary file. Now, so if you want to read data from binary file, so reading from binary file, we want to read the dictionary that we have saved in binary format. Okay, so I'll do it. We'll say import pickle. We'll open this file, which is dict.dat, and we'll open it in read binary mode, and then we'll say data D is pickle.load. So we'll be loading this file f, and we'll print D. Finally, we'll close this file. So I'll just right click here and run it. So here we have printed this D, like we have loaded this file and we are printing it. So it has given me this dictionary. Okay, it was reading this dict.dat, and what is inside dict.dat? This binary data. So what pickle.load is doing, it is converting this binary data into back into original Python object. This original Python object here in this case is this dictionary. Okay, and we are able to read this dictionary. So this process is called deserialization. Here while writing we did serialization, pickling of file, and here we are unpickling it. This is called deserialization. Okay, so the next topic is creating, opening and closing binary files. So in Python, binary files are handled using binary modes such as read binary, write binary and append binary. So we can open it for writing, we'll be opening it in write binary mode, for reading in read binary mode, and for appending in append binary mode. Creating a binary file. A binary file is created using open function. We just saw it, how to create a binary file. We use this built-in open function to create binary file. With write binary mode, because we are creating this file, so we'll be opening it in write binary mode. Syntax is file object is equals to open file name dot that in write binary mode. So we'll be using this write binary mode. We are writing into this file which is called file name dot dat. So example is open student dot dat in write binary, print binary file created f dot close. So we are opening this student dot dat file and we are opening it in write binary mode for writing data into this. This is basic example we have shown how this file is created. If file already exists, its contents are overwritten. Next is opening a binary file. So we just saw how binary file is created. Now whenever we open a binary file, we can open it in these three different modes, which is read binary mode. So in case if we are opening it for reading purpose, so we'll be opening it in read binary mode. If we are opening it in for writing purpose, in write binary mode, and for appending purpose, append binary mode. Okay, so these three modes are available. Opening for reading. So in case we are opening the file for reading, so we say open file name dot dat in read binary mode. Opening for appending. So here we are opening this file name dot dat in append binary mode. We want this file to be appended. Next is closing a binary file. So after completing file operations, the files should be closed using the close method. So we say file object dot close. So we have to close this file once we are done performing operations in the file. So closing is important because it saves all changes permanently, free system resources, prevents data corruption and avoid memory wastage. So in order to free the system resources and save the changes, we have to close the binary file after we are done working with the file. Okay, so the next topic is writing onto a binary file, and this process is called pickling. Okay, so writing data onto a binary file using Pickle module is called pickling or serialization. So whenever we write data inside binary file using Pickle module, that is called pickling or serialization. In this process, Python objects are converted into binary format and stored in binary file. Okay, so we have our original Python object. We'll be converting it into binary format, and once they are converted into binary format, we will be storing them in a binary file. And how do we do it? We do it using pickle.dump. We say here we put the object, and then here the name of the file where we want it to be saved. So I'll just show one example on Python. Okay, let's say our problem statement is a binary file items.dat contains records stored in the following format: item ID. Inside item ID we have item name and amount. This is the format. We want to write a function copy new that copies all records whose amount is greater than 1000 from items.dat to new items.dat. So let's say our dictionary is, we have this item ID 101, and corresponding this item ID we have this is item 1, and the value is, let's say, 1001. Then we have item ID 102 and the value is item 2 1000. Then we have item ID 103 and this is item 3 and value is, let's say, 999. Then we have item ID 104 and this is item 4 and the value is, let's say, 1005. This is our data. Fine. Okay, so first what we'll do, we'll create this items.dat file. So we'll say import pickle. So, and we are opening this file which is items.dat in write binary mode, because we are writing this data. Data is this dictionary, and finally we will say pickle.dump this data in this file, and then we'll close this file. Okay, so if I'll just right click here and run it, so this items.dat file is created. Okay, this is my items.dat file. Now what we are supposed to do is we want to write a function copy new that copies all records whose amount is greater than 1000 from items.dat to new items.dat. So first we'll create this function copy new. We'll put our program inside this try except block. Try except if we encounter file not found error, so we'll just print. Okay, so here we'll open this file with open items.dat and we are opening it in read binary mode as F1. We say data 1 is pickle.load F1, so we are loading this data. Data 2 is an empty dictionary. Now we'll say for k and v in data 1 dot items. Okay, so I'll just here we'll print data 1 dot items so that it becomes clear what k and v value are going to be. So we say if this v at index 1, so see, this is the key 101 and this is the value item 1 and 101. Okay, so here for this key is 101, v is this list. So here at 0th index item 1 is present, at first one index 101 is present. So we are comparing this value with 1000. So we say v1, if v1 is greater than 1000, we say data 2 key is equals to v. We will be storing that in our data 2. Now we say with open new items.dat and we are opening it in write binary mode as F2, and here we will dump that data pickle.dump data 2 in this file F2. Okay, here this we will be learning in detail about this try except, this exception handling in the next chapter, but for now you need to understand that in order to handle this file not found error, we need to put this code inside this try except block. Okay, so now once this function is created, we have to call it here. So we are calling this function copy new. I'll just right click and run it. So here see, this new items.dat file is created, and because here we printed this data 1.item, so it has printed me this data items. Okay, this is printed because I just wanted to show you what this k and v are in data 1.items. This will be the k value and this will be the v value, and inside this v value item 1 is at 0th location, item 1 is at index 1, so that is why we are comparing v1 with. Okay, I hope this much is clear. And if we see new items are that, so this is the binary file which is created. Now if we want to check what this new items.dat file contains, so what we'll do, we'll just say f is equals to open new items.dat and we want to read this data, read binary. So we are opening this file and we say d is equals to pickle.load and we are loading this file f, then we want to print this d, and then finally we are closing this file. Okay, so if I just right click here and run it, see, so this new items.dat file has this data. So 101 item 1 and the value is 1001 because this value is greater than 1000. Then we have 104 item 4 and the value is 1005 because 1001 is greater than 1000, so it has taken this this data, and here 1000 is not greater than 1000, 999 is not greater than 1000, and again 1005 here is greater than 1000, so it has again taken this part of data. So I hope this is clear, and so I can just debug it and show you how this is working. So here I debug it. See, when I am opening items.dat as in read binary mode, so data1 is, it is loading this file. So in this file F1 we have this data 101 and all this this particular dictionary, where this is the key 101 and this is the value item 1 1001, then this is the key 102, then it is the values item 2 1 and 1000. So this this entire dictionary is loaded here and it is stored in the as data 1. Now we have this empty dictionary data 2. Now if I'll move here, so we have we are printing data1.item. So I'll just move to console and we'll see data items are these are the data items. Okay, next if we see the key and value in data1.items, so here key is 101 and value is item 1 and 1001. so here at 0th index item 1 is present, at first index 1001 is present. So if value 1 is greater than 1000, so here in this case value 1 is greater than 1000, yes, so data to key is equals to value, so this will come inside here. So data 2, this key and value are stored here in data 2. Now next again we'll loop through the data. So now the key is 102 and value is item 2000. Now 1000 value v1, we'll check here in this condition, is it greater? No, so it will come out of the loop here. Next again we'll check for the next value, we'll check key is 102 and value is item 2 and itna. So now it will check here v1, whether v1 is greater than 1000. So v1 is not greater than 1000, so it will come out from here. So again now next value is, it will check for the next value. Next value is k is equals to 104 and value is this. Now 1005, so v1 is 1005, whether 1005 is greater than 1000, yes, so it will come here and it will data 2, there's this key and value will be stored again in data 2, and this data 2 has two keys 101 and 102, and this is the data which is stored in data 2. So and then what we are doing, we are opening this new item.dat file as F2 and then we are just dumping this data. So this is how it is working. So the next topic is appending records in binary file. Appending means adding new data at the end of an existing binary file without deleting old contents. Okay, so we are just adding new data. Okay, we are adding new data at the end of the already existing file. So data is already there and we want to add some extra data, so we do it using append, because if we use it using write, if you open that file using write, it will overwrite the existing data. So in order to retain our original data and just make changes there, write extra data at the end of it, we need to open it in append mode. In Python, binary file are opened in append binary mode for appending records. Python uses Pickle module to append Python objects into binary file. Okay, so we do it using Pickle module. I'll just show you on PyCharm. Okay, let's say our problem statement is program to append a student record into a binary file using Pickle. We want to append a student record into a binary file using Pickle. Okay, let us just create student.dat file first. So we say import Pickle file open. We are creating this student.dat file and we are creating it in write binary mode. Then we say pickle.dump and let's say this is our data, this is the roll number, name is Aman and these are the marks, and we are dumping it in this file. Then we say pickle.dump, this is the next record 102, name is Amita, marks are 98, and then we are storing it in F file, and then finally we are closing this file. Okay, so I'll just right click here and run it. So this student.dat file is created. Now I'll just open this file student.dat in append mode for appending the file student.dat, and I'm opening it in append binary mode. So we will be inputting this data. So first we'll input roll number. We'll say enter roll number. Then we'll input name, enter name, and then finally we'll input marks. So and then we will create this record student, and inside this record we have this roll number, name, marks. Finally we'll be appending it using Pickle. So we say pickle dot dump, and we are dumping this student in this file F, and next we'll close the file. Okay, so we are opening this. Okay, so I just right click here and run it. It is asking me enter the roll number. Let's say I enter it. The roll number is 105. Name is Ambika, and marks are 99. Okay, so now if I want to check whether it has been updated, so what we'll do, we'll just open this file. We'll open this student.bat file in read binary mode, and I'll say d is equals to pickle dot load this file F, then we'll print d, and then finally we'll close the file. So I'll just right click here and run it, and it has given me just one record, because we have to put this inside loop to get all the records. While true, d is equals to itna, and print, and we need to put this inside try except block, except end of file error dot close. So I'll just right click here and run it. So it has given me all the records. So this appended record 105 Ambika 99, it is also printed here. Okay, so this is how it is done. We just saw how appending is done. Okay, so next is reading from binary file, unpickling. So reading data from binary file using the Pickle module is called unpickling or deserialization. We have already read about this, that whenever we read binary file using Pickle, so we have to load that data. So that the file which is a binary file which has data in binary format is to be converted in its original Python object, and that process is unpickling or deserialization. In this process, binary data stored in the file is converted back into original Python object. Syntax is pickle.load file. Fine. Now pickle.load raises end of file error. So when reading multiple records from binary file, pickle.load keeps reading object one by one. So whenever we are reading multiple records from a binary file, so pickle.load will keep reading objects. So we have already seen in our program, we will keep pickle.load inside a loop, where there we had kept it inside while loop, where we said while true pickle.load. So what pickle.load will do, it will keep reading objects one by one. So at the end of the file, no more data is available, obviously. Now the pickle.load raises end of file error. It does not know where to end. Okay, it will keep reading now, but we have already reached the end of the file and no more data is available. So what happens is pickle.load raises end of file error. Now to handle this error safely, we use try except block. So we used try except block because we wanted to handle this end of file error. Without using try except, it would throw us this end of file error. Or we use with statement with try except block. See here, this is the example. We're importing Pickle. We say open student that in read binary. This is the if we are reading this finally student.dat, file is already present. We are reading that file. Now when we say, now let's say student.dat, it has data. Let's say it has data, this roll number, and name is Aman, marks is 95. 102, name is Amita, marks is 98. Let's suppose this is the data of student.dat file. Now it is saying while true, data is equals to pickle.load f. So when we'll say pickle.load f, will load this data. Okay, it will read this line and it will print that line. Next, because we are inside this loop, and it will read this line and print that line. Now we have, like, it has reached the end and there is no more data is there. So what will happen is, if this except EOF error was not there, it would give us end of file error. But here we have, by using exceptional handling, we have handled this. So it will come here and it will say print, it will print end of file reached, and then finally we'll close the file. So pickle.load reads one object at a time. When all records are read, E of F error occurs, end of file error occurs, except end of file error handles the error and stops the program safely. So whenever we do except end of file error, so this handles the error and the program is stopped. Now using with statement automatically closes the file after use. So here we can see we had to explicitly close this file, but in case of with, we don't have to write f.close. So here we are saying open student.dat read binary as f. Now again, so we say while under the try block we say while true, data is equals to pickle.load f print data, and then under the except E of F error we say print end of the file reached. So again inside this loop it will keep printing the data until it reaches end of file. When it reaches end of file, this loop will come here and it will simply print end of file reached. See, the with statement automatically handles file closing, but it does not remove the need for try, except and all. Okay, so if we don't have to explicitly write f.close when we are using with statement, but we have to use try and except for handling end of file error. With does not handle errors like end of file and file not found error. So while reading binary file using pickle.load, we still need try except E of error, because pickle.load raises E of F error at the end. So even if we are opening file with the help of with, we have to handle our end of file error or end file not found error. Okay, with only manages opening and closing. Fine. So I'll just show this on PyCharm. I'll debug it on PyCharm and show you how it is working. Okay, so we had already written this program. I'll just debug it here and show you. Okay, so here let us just print end of file reached. Okay, so these are my debug points. So let me right click and debug. Okay, so here we already have this student.dat file. This is our student.dat file. Okay, so it has loaded student.dat file. Now d is equals to pickle.load. It will load it, and so it has read this data 101 Aman 95. Okay, it will print this, and if we see in the console, it has printed it here. Next, it will load this data 102 Amita 98 and it will print it. Next, it will load 105 Ambika 99 and then it will be printed. See, it is printed. Now there is no more data. We know there is no more data. So again, when we'll do it, so the control, it moves to this in the except block and this will be printed. End of file reached. It has printed and finally our file is closed. So this is how it is working. Now let's say if we do not put it inside try block. So if I'll right click here, I'll just close the file. So I'll just right click and debug this. So here first it has loaded this. Okay. Next it has loaded this 102 Amita 98. Fine, and it has printed this on console. Next it has loaded this 105 Ambika 99 and this will be printed here. Fine. Next, see, it gives me exception end of file error ran out of input. So this end of file error has occurred. So using this try except, we can handle this end of file error and our program runs smoothly. Fine. Okay, we just saw how this E of file error is handled in binary files, but in case of text files, we read data through line is equals to f dot read line. Okay, so and it returns an empty string at end of file. So in binary file with pickle.load, no empty value is returned and exception E of is raised instead. So in case of binary file, no empty value is returned and exception E of error is raised instead. And in case of text file, it is giving us an empty string. Okay, and in Python an empty string is treated as false in Boolean context. So when we say, like example, when we say f is equals to open sample.text and we are opening it in read binary mode, we say while true. So this is our loop and we read it using line. f dot read line. So we say if not line, then we break out of loop, else we print line dot r strip, and then finally we close the file. So here we are reading this file using f dot read line, and we are saying if not line. So if line equals to blank string. So okay, this means if line equals to blank string, that is if we have reached the end of the file, then we break out of loop, else we print line dot r strip, and then we finally close the file. So if our sample.txt had this data, apple, banana, mango, so what will happen is when we'll read the first line inside, because we are inside this loop while true, so it will keep reading using f dot read line. So it will read the first line, it will read this value of line is apple, new line, and since we are using r strip, so while printing it will only print apple, and this boolean value is right now it will stay true. It will again go inside the loop while true, yes it is true, so it will go to second line is banana, and again at this time true, while is this boolean value is true. Then we'll read the third line. In the third line we have mango, either we have mango or with mango with a new line, and again this boolean value is still true. So then again boolean value is true, so it will again read f dot read line. So here we will encounter this empty string. So when we encounter this empty string, see it's when we encounter this empty string, so if not line will become true, and it will break out of the loop. So this value, boolean value here, it will become false. This it will, if not line will become, because line has become this empty string, and it will break out of the loop. So the loop terminates. Fine. So this is how it is working. I hope the writing is not very difficult to read. So we will see the difference between with statement and try except. So with statement automatically closes the file, so we don't have to explicitly write f dot close. Try except is exceptional handling, so it handles runtime errors. This is used for resource management. It will empty the resources used in the file as soon as the work is done. This is used for exception handling, does not handle E of file error, and it can handle end of file error. Next is searching in a binary file. So in binary file, records are read using pickle.load and compared with the search value. So here what we are doing is we are importing pickle. Fine. We have this variable and we have assigned value false to it. Fine. Now we say with open student.dat in read binary. We are opening this file in read binary. Then we are using this try except to handle end of file error. So inside this block, try block, we say while true. So we have this loop so that it keeps reading the data. We are saying data is equals to pickle.load f. Fine. Then we say data 0 equals to 101. So here we are searching it. We are saying if the data at the 0th index, if it is matches 101, then we print the data, the found value becomes true, and we break out of the loop. Or else we keep loading next value, and then we search whether the value at 0th location is 101 or not. And then finally when we break out a loop, since value it becomes true, so this record not found will not be printed. Fine. I'll just show it on PyCharm. Okay, so we just say import pickle, then we have this variable found is equals to false. Next we'll open this file student.dat, and we are opening it in read binary mode as f. So inside this try block we say while true, data is equals to pickle.load f. If data at 0th location equals to 101, then we print data found is equals to true, and we break out of loop. Okay, then inside this except block we say pass, and if the value of found equals to false, we say print record not found. Okay, so I'll just first show you what is inside student.dat file. So I'll just right click here and run it. So this is our student.dat file. This is the data. Okay, I'll just comment this out and run it again. This is the data 101 Aman 95, 102 Amita 98, 105 Ambika 99. Okay, so this is the data of student.dat file. Now we are searching this value 101. Okay, data 0 equals to 101. I'll just right click here and run it. See, so when data 0 equals to 101, so it has this value, data 0 equals to 101 is true. So it will print this data. So this data 101 Aman 95 is printed. Okay, let me make this data 1 to 1. If I do this, see, it gives me record not found because that value is not present in student.dat file. See, I'll just show you once again. This is the data. Okay, right click here, and so this is the data. Fine. So when I said 1 to 1, because 1 to 1 key is not present here, so it gives me data not found. Now if I say 102, I'll right click here and run. So corresponding to 102 key, this is the data 102 Amita 98. Fine. Okay, I'll just right click and debug it. So first our data is this 101 Aman 95 at 0th index. The value is 101 and we are checking at 0th index. Data 0 equals to 102. So we'll see came out of the loop because 101 is not equals to 102. Next it is checking for 102. So here it will get inside the loop because it has matched. Then we'll print the data. So in console it is printed and value of found becomes true. Then it will break out the loop because we have already found the value we were looking for, and then this is the output. So this is how it is working. So next is updating records in a binary file. So updating in a binary file means modifying an existing record stored in the file. So we already have an existing record and we just want to update that record. We just want to modify that record. So since binary file do not allow direct modification of records easily, the common method is read records from original file, modify the required record, write records in a temporary file, and replace the original file with the updated file. Okay, so this is the process that we need to follow. Okay, so originally first what we'll do, we'll read the record from the original file, then we'll modify that record, then we'll write that record in the temporary file, and then finally we'll replace the original file with the updated file. So Python uses Pickle module for handling binary files. So I'll just show this on PyCharm. In this program we will program to update a record in student.dat file. Okay, so how we'll do it, we'll say first import Pickle, import OS, then we'll say found is equals to false. So we have this key found and we are assigning false value to it. Next what we'll do, we'll open our student.dat file and we're opening it in read binary mode. Then we'll open this temporary file temp.dat and we are opening it in write binary because we'll be writing inside this temporary file. Next we'll put our code inside try block, try and except. We'll be using except for end of file error, pass, and finally we'll close the file f.close and temp.close. So here we'll be writing our code. So we say data equals to pickle.load f. So first initially what we'll do, we'll load the data from this file student.dat, then we'll search the record. So if data at 0th index is equals to 101, then we print old record data and we will update marks. At second index we have our value marks and we'll update our marks to, let's say we'll update to 100. We say print updated record data, then we say found is equals to true because we have updated it, and finally we'll say pickle dot dump this data in temporary file. So if I'll just right click here and run it, so it was giving me, because we were searching this record which matches 101 value. So this is a record 101 Aman and here the marks were 95, and because we updated the marks, data 2 equals to 100, we updated the marks. So here it has given me 101 Aman 100 because we are printing updated data, and we have put this updated data inside this temporary file. Now what we'll do is we will os.remove, we'll remove this student.that file, and we'll say os.rename. So we'll rename this temp.dat file with student.dat file. So we have renamed temporary file to student.dat. So if found, the found value becomes true. So we say record updated successfully. Else what we do, we print record not found. Okay, so I'll just right click here and run it. So it has said record updated successfully. If I say here find record 151, so I'll just right click here and run it, and it says record not found. Okay, so this is how we update records. We find the record that we need, we search for the desired record, we make changes to it, then we store that in the temporary file, and then finally we displace the temporary file with the original file. So a temporary file where the updated record is present becomes the original file. So I hope this is clear. Okay, so the next topic is accessing and manipulating location of a file pointer, random access. So a file pointer is a marker that indicates the current position in a file from where next read and write operation will take place. So what is a file pointer? It is a marker. It marks the current position of a file. Whatever position from where the next read and write operation will happen, that particular position is marked using file pointer. So file pointer is kind of a marker. Okay, it tells us that that particular position. Normally files are processed sequentially, but sometimes we need to directly move to a specific location in a file. This is called random access. So if we want to jump to a specific location, we need to know the location of that location. So we make use of file pointer in such case. Python provides two functions for random access, tell and seek. Tell function returns the current position of the file pointer. Like we have open data text in read mode, f.print f.tell. Since we are opening it in read mode, when we say print f.tell, initially it will be at position 0. Then we say f read 5. So let's say our file has this data, which is Python is cool. Now we are reading first 5 letters. So we have like 0, 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. So we are reading till here. PYTHO. Okay, we are reading till here. So our file pointer, since once we read f.read, so we have read till here. File pointer will come here. So when we say f.tell, so file pointer is at location 5. Okay, file pointer is at location 5. So f.tell will give us 5, and then we'll close the file. So initially file pointer is at position 0, and after reading 5 characters, file pointer moves to position 5. Now seek function is used to move the file pointer to a specific position in the file. Syntax file object dot seek offset position to move the file object. Okay, so using seek we can move that position to a specified point. Like when we say open data text in read modes, it is opening it in read mode, and initially the file pointer is at position 0. Now when we say f.seek3, seek moves pointer to position 3, and then when we read, we will be reading from that position 3. So if we had this data Python is cool, like we saw here, if we had data, so what is that? It is reading f.seek3. So 0, 1, 2. So from the file pointer will come here, and from it will read from here. Okay, from this point, because it has read first 3 characters. Because seek will move the file pointer to the third position. Okay, I just show it on Python so that it becomes clear. Okay, so let's say we open this file notes.txt and we are opening it in read mode. Then we say print initial position, and we say f.tell. It will give us the initial position of the file. Then we say f.seek4. Then we say print new position, and we get it by using f.tell. And if I try to read f.read from that particular position, and then finally I close the file. Okay, so my notes.txt, this is my notes.txt file, and if I right click here and run it, so it gives me initial position is 0. So because when we start reading from the file, it starts from the 0th position. Next, if we are saying f.seek4, so new position will be 4, and then it will start reading from that point from that new pointer, and it will read this, because this notes.txt is here. So 0, 1, 2, 3 and 4. So 4 is here. This is at H. At H the pointer will be there. Okay, this is the fourth. This is the new pointer location, that is 4, and it will read this handling in Python. Okay, so I hope this is clear. So we just saw random access. Random access means directly accessing any position in a file without reading all previous data. Okay, we can access any position in a file using random access. It is useful for updating records, searching large files, and fast data retrieval. Difference between seek and tell: seek, it moves file pointer; tell, it returns current position. So we get the current position using tell, and what is seek doing? It moves the file pointer to a desired location. By using seek, we can move it to a desired location. This is used for random access, that is tell is used to know the pointer location. Now next is updating records in a file. So in binary file, records can be updated using the position of the file pointer. So if we know the position of the file pointer, we can directly move to that position and update the record. So rpos is record position, or the position where the particular record starts in the binary file. So from rpos is record position, so we want a particular position. If we want to store that particular position from where that particular record is starting in a file, that desired location, we can store it as rpos. Before reading a record, we store the current file pointer using rpos is equals to f.tell. When we say f.tell, it gives us the current location of the file, and we can store that as record position, so that we can move back to this particular position after moving to any desired location. And if we want to move back to the initial position, we can use it using rpos. This position helps us move back to the same record later using seek and update it. So we'll just say f.seek that particular position rpos, and we'll move back to that initial position. Okay, this method is called random access updating, that we are updating record in a file using this record position. So I'll just show how it's done on PyCharm. So here, this is a program to update record using rpos, that is record position. Okay, so initially first we'll import pickle, and we say found is equals to false. We have stored this key, found is equals to false. Next we'll open this file with open student.dat in read binary mode. We are using in read binary plus mode because we will be updating the record of the file as f. If we put the code under try except log, so here we'll say while true, we say rpos record position is the current position of the file f.tell. It will store the current position of the file. Then we say data equals to pickle.load. Next we are searching the record. If data 0 equals to 101, then print old record data. Here we'll be updating the marks. So data at index 2, we'll update that marks to, let's say, 97. Next what we'll do, we'll move this pointer to its initial position. We do it using seek, and we'll move it to, we have stored the initial position at rpos, so we'll say f.seek rpos. Next we will rewrite this data pickle.dump data f, and we'll say print updated record data. We'll just say found is equals to true, and finally we'll break out of loop, and we say if found, then we'll print on updated successfully, else we'll print record not found. Okay, so I'll just right click here and run it, and here it says old record 101 95. So we searched data 0 equals to 101. So for this corresponding, it has like this condition matches here, and we say old record equals to data, so old record it will be printed. Then what we're doing, we are changing data at index 2, so 0 1 2, at this index 95 we are changing marks to 97. So here we are moving back to the initial position rpos, and then we are dumping this data in the file, updated record data. So updated record is 101 Aman 97, and we say record updated successfully. Now if I say 102 and right click here, so 102 is this record, 102 Amita 98, and here also we have updated the marks to 97. So I'll just show you by reading this student.dat file. So I'll right click here and run it. So here, see, this is the updated file, and at both these position 97 is updated. So that is how this is done. Okay, so the next topic is working with CSV files. So a CSV, comma separated values, is a special type of text file used to store tabular data. So if our data is in the form of tables, so if we have tabular data, then we store it using CSV file. Each line in the CSV file represents a record, and the values within the record are separated by commas. Let's say we have this employees data file. Okay, so we have this name of employee, then we have a gender of employee, and we have salary of employee. So let's say our name is Aman, gender is male, and salary is 10 lakhs. Then we have Amita, gender is female, and salary is, let's say, 20 lakhs. Okay, so this is how CSV file is stored, and this is a record and this is a record. So these are two records which we can see, and all these records are separated by commas. Although commas are the default delimiter in CSV file, other characters such as semicolon, colon, tab can also be used to separate values. Fine. CSV file are useful for storing and transferring structured data. The next is Python CSV module. So Python provides a built-in CSV module that makes it easy to read from and write to CSV file. So we have this built-in CSV module that makes it easy to read from and write to CSV file. We do it by importing the CSV module. We say import CSV. The CSV module provides two specific type of objects, the reader and writer object, to read and write into CSV file. So when you want to read from the CSV file, we say csv.reader. It reads data from a CSV file. And if you want to write into a CSV file, we say CSV writer. It writes data into a CSV file. Okay, so next is opening and closing CSV files. So before reading from or writing to a CSV file, the file must be opened. So we need to open the CSV file in order to read or write from it. Okay. After the operation is completed, it should be closed to free system resources and ensure all the data is properly saved. Fine. So opening a CSV file, we say open file name.csv and the mode in which we want it to be opened. That is how we open a CSV file. The common modes are read mode, read an existing CSV file; write mode, write to a CSV file, creates a new file or overwrites existing content; A, append data to an existing CSV file; and R plus, read and write both. Now closing a CSV file. So we do it using f.close. This is the syntax. Why close a file? It releases system resources, ensure all buffer data is written to the file, prevents data loss or file corruption. Okay, so this is the reason that we need to close our file, because basically we need to free release the system resources and ensure that all the data is stored perfectly. The with statement automatically closes the file after use. No need to write f close explicitly. So we have already seen here also, when we open a file using with statement, we don't have to explicitly write f.close to close the file. So this is the example, import CSV, and we are opening this file student.csv in read mode. We say csv.reader f, and for row in data, print row. So let's say a student.csv file has data. Let's say this is the data, roll number, name, marks. So let's say roll number is 101, name is Aman, marks are 89. Then roll number is 102, name is Ria, marks are 95. Then we have roll number 103, name is Karan, marks are 78. Okay, so let's say if this is our data and we are opening this student.csv file in read mode, we are doing it using data is equals to csv reader f. So using csv.reader f, we are reading the data. So we say for row in data, print row. So here we are printing each row one by one. So first this will be printed, then this will be printed, then this will be printed, then this will be printed. Okay, and then finally we say f.close. Here we are doing the same thing using with statement. So we are saying with open.csv read as f. Then we are saying data is equals to csv.reader f. So here we are reading the data using CSV reader file, and then for row and data print row. So we are printing each row. So we haven't written f.close here because we are using with. Now role of a new line argument in opening CSV file. So when writing CSV file, Python may insert extra blank lines between records or on some operating systems, especially Windows. So while writing, sometimes it may happen that extra blank lines are inserted in between records. So in order to ensure that no such extra blank line is recorded, you make use of this new line is equals to double quotes. So we say f is equals to student.csv in opening it in write mode, and new line is equals to this. Okay, so this is how we open the file. When we open the file in this manner, then no extra blank lines are recorded. So you say, see, student import CSV, f is equals to student.csv write, new line, this double quotes. We are writing into the file using csv.writer f. Then wr.write row, we'll be writing this first row, roll number, name, marks, then this row 101 Aman 89, and then finally we're closing the file. So here new line, this is used. It prevents extra blank line between records, allows CSV module to handle line endings correctly, and recommended whenever CSV file is opened for writing. So whenever we are opening it for writing, it is recommended that we use this new line is equals to this double quotes. Writing in CSV file. So in order to write into CSV file, the user data is converted into writable delimited form and then stored in the form of CSV file. Okay, so we have to convert that data, in whatever format the data is there, we have to convert it into writable delimited form, and then it is stored in CSV file. To write data into CSV file, Python provides CSV writer function. We just saw it. The writer function can write data using write row. It writes a single record, one row, and write rows, it writes multiple records, many rows. See, here we are making use of write row. So writes one row at a time to the CSV file. It writes one row at a time. So we have this writer.write row record, where record is usually a list or a tuple. Okay, so we have import CSV, then we are opening the student.csv file in write mode, new line is equals to this. Then we are writing the file csv.writer file. So here what is happening is we are making use of this write row to write one row. This is, it will be written roll number, name, marks. Then we say write wr.write row. Then this line will be written 101 Aman 89. Then we are saying wr.write row, and then this line will be written. Okay, so using write rows, single records will be written into the file. It writes one row at a time, and the record is usually a list or a tuple. In this case, this is a list. Then we have write rows. It writes multiple rows at once, multiple rows. So we have the syntax writer.write rows records, where records is a list of tuples. So here it is a list of lists in this example. So what we are doing is we have this, we are importing CSV file, then we are opening this student.csv file in write mode, new line is equals to this, and then we have csv.writer f. So using the csv.writer file, we are writing into the file. We have these records, roll number, name, marks, and 101 Aman 89, 102 Ria 95, 103 Karan 78, and this is in the form of list of lists. So we are writing this entire record using write rows. So when we say write wr.write rows records, so this entire record will be written into the file, and finally we are closing the file. Difference between write row and write rows. So write row, it writes one record at a time. This writes multiple records at once. This takes a single list or tuple. It takes a list of lists or tuples. Okay. Call repeatedly for multiple records. It is called once for all records. Useful when records are entered one by one. Useful when records are already available in a collection. So when we have huge collection of records, then we don't have to write one by one. We can write the entire collection at once using write rows. Now reading in CSV files. So CSV reader function is used to read data from a CSV file. It returns an object that reads the file row by row, where each row is represented as list of strings. So it returns an object that reads the file row by row. where each row is represented as a list of strings. So see, we have this import CSV, then we are opening this file name .csv in read mode, and then using data, we are saying data is equal to CSV reader F. So using CSV reader, we are reading this CSV data. Okay, so we'll just do some practice questions on PyCharm so that all the topics of working with CSV files become clear. Okay, so we'll start with a program. Create a CSV file and store student details. Which are the student details? These are roll number, marks, name. Okay, so we have to create a CSV file and store these student details. So how do we do it? First we import CSV, and we say file is equals to open student.csv file, and we are opening it in write mode, and we say new line is, so we are writing wr is equals to csv dot writer file. We'll say wr dot write row. Inside write row we'll write roll number, name, marks. Then we'll say dot write row, and inside that we'll write 101 Aman 89 dot write row. Inside that we'll write 102 Amita 95, and then finally we'll close the file. So if I'll right click here and run it, so we see this student.csv file is created, and this is our file. We have roll number, name, marks, 101 Aman 89, 102 Amita 95. This is separated by the delimiter is comma. This is a comma separated value file. Okay, next is if we want to write multiple records using write rows, and you want to store a list of student records in a CSV file. So we say import CSV. Now we have records is equals to, so inside this list we have these lists: roll number, name, marks. 101, name is Ankit, marks are 92. Then 1 and 2, name is Ankita, marks are 91. Then we have 113, name is Rita, marks are 89. Okay, so this is our record, and then we say f is equals to open, we say student1.csv, and we are opening it in write mode, and we have new line is equals to this. wr is equals to csv dot writer f, wr dot write rows, and inside it we say records, and then finally we say f dot close. So I'll just comment this out here and right click here. So we have this student1.csv file, and this data is stored here in it. Okay, so next is read contents of a CSV file and display them. So we say import CSV, file is equals to open student.csv, and we are opening it in read mode, and we say data is equals to csv dot reader, this file. So for row in data, print row, f dot close. Okay, so I'll just right click here and run it. See, one by one it will read row from this data, and we are reading this data using CSV reader, and it has printed these rows. Okay, so next is search for a student by roll number or name. So again we'll say r number equals to input, enter roll number, f is equals to open students.csv, and we are opening it in read mode. Then we say data is equals to csv dot reader f, and then we say next data. Why are we doing this? Because we want to skip the first row, because the first row is this roll number, name, marks. Okay, we want to skip it. Next we say for row in data, if row 0 equals to r number, then we print that particular row, and finally we close the file. So here what we are doing is, we say for row in data, we'll be looping through each row in the data. And if we say row at 0th index, because at 0th index this roll number is present, if row at 0th index equals to roll number that we have inputted, if that is there, then we'll be printing that row, or else we'll not be printing that row. So just right click here and run it. It has asked me the roll number, so let's say roll number is 101. So this row is printed. Again I'll show you. Right click here and let's input 111. So nothing is printed. Then I'll again right click here and run it, and then I'll say 102. So this is printed. Okay, so if it matches here with element at 0th index, that is the roll number, if it matches the roll number, then that row will be printed, or else it won't be printed. Okay, next is count the number of student records. So we open this file. Let's say we open this student1.csv and we are opening it in read mode. Then we say data is equals to csv.reader this file. We say next data, because we will be skipping the first row. Then we say count is equals to 0. For row in data, count plus equals to 1. Then we print total records count, and finally we close the file. Okay, so here what we are doing is we have taken this variable count and assigned value 0 to it, because right now count is 0. And when we are moving inside this loop for row in data, okay, so it will read the first row, because we have skipped the header. So it will read the first row and it will count it. Then it will keep on counting till data is present. So if we have this student1.csv file, it will skip this because we are skipping using next data. Then it will come here, it will count, then it will count, will increase. First it will count this, count will go from 0 to 1, then it will count this, count will go from 0 to 2, then it will count this third, and count will go from 2 to 3. Okay, so I'll just right click here and show you. So total records is 3. Fine. Okay, so next is display the names of student scoring above 80 marks. First we'll open this file, that is student.csv in read mode. Then we say data is equals to csv.reader this file. We'll do next data to skip the header. Now for row in data, if int row 2, because see, so this is a student.csv file. So here we have roll number, name and marks, and we here in this case we are comparing the marks. If the marks are above 80, then we'll be displaying their names. So here at 0th index 101 roll number is there, at name at first index name is there, and at second index this marks is there. So we say int row 2, if greater than 80, then we print, what do we print? We print the name of that particular student. Print row 1. Why row 1? Because at first index here, at first index name is there. Okay, then we'll just close the file. So I'll just right click here and run it. So it has given me Aman and Amita, because in my student first you'll compare this marks. So 89 is greater than 80, so it will print Aman. Then it will compare this marks. So 95 is greater than 80, then it will print Amita. So next is program to add new record to an existing CSV file. Okay, so let's say we are opening this student.csv file, and since we are adding a new record to an existing record, so we'll be opening it in append mode, and new line is equals to this. So I'll say wr is equals to csv.writer f. We'll say wr dot write row, and the row is 103 current 78, and close the file. Okay, so I'll just right click here and run it, and we'll check our student.csv file. So here this 103 current 78 is added, it is appended. So next is store records as dictionaries. So we want to store a record in the form of dictionary. And how are we going to do it? So we'll say f is equals to open, let's say this is student3.csv. we are opening it in write mode, new line this. Next, fields is equals to, what are the fields? Roll number, name marks. These are the fields. Then we say WR is equals to CSV dot writer. Here in this case, we'll say CSV dot dict writer. Why? Because we want to write in the form of dictionary. And then I'll say F, we're writing this file, and the field names are fields. Okay. Next, we say WR dot write header, and this is only available with CSV dot dict writer and writes field names as the first row. And then we say WR dot write row, and inside the row we'll write this dictionary, which is roll number is 101, name is, let's say, Akash, and marks are, let's say, 97. Finally we'll close the file. So if I right click here and run it, so here we get student3.csv and it has written roll number, name, marks. This is the header, and this file is written into it. Okay, so this is how we do it using dict writer in the form of dictionary. Next is read and display values using field names. So here again we open this file student.csv and we are opening it in read mode. So we say data is equals to CSV dot dict reader. So this is how we are going to read the file. So we say for row in data print row, and we want to display the field names, and then finally we close the file, dict reader and this file. So here in this case, when we are using dict reader, so when we said for row in data, so we are saying print row name, so we can access the names using this field name, and we can do it because we are reading through dict reader. Okay, so if I right click here and run it, so I get all the names Aman, Amita and Karan. Okay, so that is how it is done. Okay, so this concludes chapter 5, file handling. In this chapter we read about files, that files provide permanent way to store data for future use. We read about different files like text files, binary files, CSV files, and all these files are supported by Python. File operations including opening, reading, writing, appending and closing files. We saw all these operations, how opening, reading, writing, appending and closing files is done in Python. About various modes like read, write, append, read binary, write binary. Functions like seek and tell that enable random access in files. We read about binary files and how it can be handled by Pickle module for storing and retrieving Python objects. Then we read about CSV files and how we have CSV module in Python for working with tabular data. File handling is an essential concept for developing real-world applications that require data storage and management. I hope all the topics explained in this chapter are clear. If you find any confusion in the explanation, then please write to me in the comments. If you find this video helpful, then please like and subscribe the channel. Thank you. Happy learning.